Hello, and welcome to the ADVizE mini lecture, Making Testable Questions with Data. I'm Kristen Enner Thompson, and let's jump right in. So, when we think about the process of science or the process of making sense of information, I want us to pause for a second. So, in our last What Are Data, we talked about, or sort of I alluded to, like, data are related to our question. So then my question is sort of, okay, so when do we use data? And when are we asking questions? This is a resource from the Museum of Geology at UC Berkeley. I highly recommend it. It's awesome. You can jump in and check it out if you want, or you can just kind of generally look at this image on the screen. But just like last time, I want you to pause the recording and I want you to just think about these two questions. You can doodle your thoughts down, you can write them down, you can just think inside your head, though I encourage you at least to think out loud. I know it kind of feels crazy, but turns out there's some different things that go on in our brain. When we say things out loud, we write it down, than when we just think it to ourselves. So my questions are, where do we use data in the process of science or process of making sense of information? And where do we ask questions? Okay, think about that for about 30 seconds and then come on back and keep going forward with the video. Okay. So, a key part of questions as it relates to data are that the questions are testable. So, what the heck do we mean by that? So, we ask a lot of questions. Oh my goodness, spend any time with a toddler and you can realize that we come basically out of the womb asking questions. We are constantly trying to sort of understand and make sense of information. There are two different kinds of questions that we often ask in the education space. One of them are project or concept questions, where they can be answered by reading or asking your teacher for information. They're often questions like why or is something da 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 da. They're centered around information, known information, to be able to answer the question. It's usually something where I have a curiosity and I have an interest to know what other people have already learned or known or discovered. And so it's new for me, but it is not new for the world more generally. And so I'm looking to an individual, as I said, or to books or the internet to be able to seek that information out that's already known to answer my individual curiosity or question. And we often gather information either from one source or ideally from multiple sources when we're asking project or concept questions. This is a bit different than a testable question. In a testable question, the way we go about answering it or investigating it, because never fully answer it, is we measure or we look at the data. We make sense of the data that we have. Our question stems are often how, what, when, who, which, where type questions. Those are things we can answer with measurable or observed data. They're often centered around variables to investigate that question, specific variables or specific components of the thing that we're asking, that we have our inquiry about. And therefore, we use one to two to many of those variables or attributes to see, are they changing in relation to each other or not, or are there similarities or differences across different groups or subgroups or components of those variables or attributes. Okay, so if that's kind of the juxtaposition between a project concept question and a testable question, then how can we go about making our testable questions as strong as possible? And we can use the SMART acronym, where it is specific. So we don't want to be too broad with the question. The narrower in focus we can be, the better. That's why we avoid the kind of why. It's also why we avoid the is, because is a yes, no. And so that's too narrow. So we're going for that kind of Goldilocks in between of our other question stems. So the S is specific, the M is measurable. There are either currently data sets available, or you can go out and collect the data to investigate the question that you have. you can't just look it up in a book or Google it. You need information to be able, you need measured information to be able to investigate the question. The A is achievable. You can actually go about investigating, pursuing this line of inquiry with data for your question. So the data are available, or you can access them, or you can measure them yourselves. For example, we could ask a question about, which elements were initially part of the Big Bang in which proportions. Now, that is actually something that scientists have been studying and researching, and we could go out there and we could probably read about it, but we ourselves could not sort of tease that apart to enough of a degree that we could go find that information in a typical third grade classroom. Great question. So we might steer that to be like, oh, let's do a project to learn about what we know so far about the Big Bang, or what we know so far and what we still don't know about the Big Bang. Awesome. Go check that out. But that's going to be hard for a third grader to collect their own data or to make sense of data out there to investigate. The R is relevant. So who cares and why do they care? So it should include which of the variables, attributes that you're looking at, and or what relationship or comparison you are trying to do. And here's the kicker for our learners: less is more. So asking testable questions that are just about one variable or two variables if you have to as you get into upper elementary and middle school, but not in lower elementary school. Let's help our students from the start. Think about, okay, what is it I'm actually looking at? So rather than weather, I'm going to look at the maximum temperature. So that's an example of, and maximum temperature is important to me because it determines what clothes I have to wear when I go outside and how hot I'm going to be. Okay, so it's relevant, it's specific, it's measurable. And then finally, the T is temporally or spatially, I know it doesn't start with a T, oriented. And so what time frame are you interested in doing a comparison? What space are you interested in doing a comparison, if that's relevant? And here's the deal: most of our questions that we ask or that we're interested in or that our learners are interested in have to do with time and space. So specific, measurable, achievable, relevant, and temporally or spatially oriented is a way that we can make our questions, our testable questions, really strong and set us up for success to explore them with data, to investigate them, to pursue this line of inquiry. Okay, so that's from the start. What if our learners are coming to with us and they've got this great question, but it's not quite hitting the mark yet? Well, we can refine it to be more testable. And there are many different ways that we can refine a question. So let's not even think about our learners. Let's just think about us. Let's say we're really interested in looking at exploring how krill and baby penguins are related. Yay, baby penguins. Okay, so this is a big picture question. This is not a question, even though it starts with how, a question that we can really easily explore with data. So how could we refine it? Well, we could make it more specific by where we want to explore this question. So what is the relationship between krill biomass and penguin chick populations around Palmer Research Station? It's in Antarctica. Okay, so we've gotten really specific on the what: krill biomass, penguin chick populations, and the where, not all of the southern hemisphere where we might find baby penguins, but Palmer Research Station in one specific place in Antarctica. Or does the relationship between krill biomass and penguin chick population vary along the Western Antarctic Peninsula? Again, still, we've got to we're tied to a specific place. Or we can refine our question by being more specific of when, temporally, when are we interested in? So what's the relationship between krill biomass and penguin chick population across a season, over a year, over a decade? Doesn't matter which time frame we pick. What matters is that it's relevant to us and that we're interested in that time frame and that we specify it. Because now we've gone from looking at krill biomass and penguin chick population for all of eternity to, okay, nope, this is a manageable amount of data that I can go find to ask my question. Or does the relationship between krill biomass and penguin chick population vary over a decade? Again, we've got it bounded in time. Another way that we could refine our question is we could be more specific about what variables we are looking at, or attributes we are looking at. So what's the relationship between krill biomass and penguin chick populations? And we stop there for our upper elementary students. But maybe we're in upper middle school, and we're interested in, like, as it changes with ocean temperatures. So then we can start adding that third variable in for our students, sort of as they're looking to push the boundary some more. Or does the relationship between krill biomass and penguin chick population vary with sea ice extent? So as our students get older, we can ask more questions, and we can think about, oh, what are these other layers that are factoring in? This is why it's so important to think about what is our question, because that influences what data we need. So what could this look like? Well, why was it warm in Antarctica? Big picture question, okay? Not testable. But we could refine it to be, how did air temperature vary around Palmer Research Station, Antarctica in 2015? We've got the time, the space, we know the variable really specifically. We're looking at air temperature. It is measurable. We can measure air temperature. Well, we didn't, but somebody else did. Measured air temperature at Palmer Research Station in Antarctica in 2015, and we can go and look for those data. And then we know exactly what part of the data set we're interested in. We don't want 1992. We want to look through this data set to get down to 2015. And we don't care about any of these other variables or attributes. We just want temperature. Maybe we want all three, maybe we want just one, but that is a decision that we can make to refine, keep refining. And then that determines what data we can use to visualize it, to then say, what am I seeing? Let me explore this a little bit more. How did the air temperature vary around Palmer Research Station, Antarctica in 2015? Does this match what I was expecting? Is it different than what I was expecting? Now we're getting into the exploring and the making meaning of it. That's coming up. Before we end, I want to encourage you to again pause the video and think about these two reflection questions about refining questions or testable questions. What strategies or processes could you use or will you use to develop your testable question for your investigations based on what we just talked about? What's something you could use? How could you bring something in that we just talked about? And are there any additional supports that might help you to ask a testable question from data? You can bring those forward. So again, write it down, draw a doodle, type it into your learning management system, wherever you're at, but take the time to pause and reflect. It helps us retain things. Okay, so pause the video and then come back. Thank you so much. It's so great to talk with you and to share this information. And I can't wait to see where you all take this and what you all do with it. As always, please feel free to reach out at this contact information. If you've got any questions or requests for clarification, I'm here to help and happy to do it. Thanks so much. Have a good day.